Now we're going to talk a little bit about vector type variables in MATLAB. So when we would type who's before, when we just made some variables in MATLAB, we talked about how there was a size column, right? And that a lot of the variables that we made, a single character or a single number, would show up as a size 1 by 1. Some things like strings where we type multiple characters would show up as something like this, 1 by 5, 1 by 7. And we had said that that second size there was related to the number of characters in our string. So here, my variable first is Homer, which is 5 characters, so its size is listed as 1 by 5. And we said that the reason that the sizes are listed like this is because MATLAB is actually really good at manipulating matrices. So every variable is actually a matrix of one kind or another. We're going to start with the simplest matrices, which are scalars and vectors. So scalar is just 1 by 1. So that's what we've been seeing a lot of lately. So if we type a number, a default double, or if we even make it an integer, right, a single value is going to be a 1 by 1 matrix, which we'll also refer to as a scalar. Row vectors and column vectors are matrices that only have one dimension to them. So a row vector has one row with a whole bunch of columns, essentially, and a column vector has one column with a whole bunch of rows. So we'll say that a row vector has one row and n columns, and a column vector has n rows and one column. Whenever we talk about dimensions like this, we'll always list rows first and then columns second. So the dimensions of a matrix are always rows by columns. You can see that we can have different types in our vectors. Here's an example of a row vector of numbers, and we've already seen examples of row vectors that contain characters. There are lots of different ways to create row vectors, and I'll show you some of these in MATLAB. So we can list out the values that we want to have inside our vector. Right? We list them inside square brackets, and we can separate them either with spaces or with commas. Either one will work. We can also use a colon notation. So we would put a value, colon, another value. And we can see what happens here is MATLAB fills in all of the values between the first one that we gave and the second one that we gave, going up by 1 every time. So if I do 3:9, I get everything between 3 and 9 inclusive. I can also use the colon operator with 3 values instead of just 2. If I do something like this where I provide 3 values, I can take a look and see what happens. The value that gets inserted in the middle is actually now my step size. So I start at the first value at 3, and then I go up by a step size of 2 every time. So 3 plus 2 is 5, 5 plus 2 is 7, 7 plus 2 is 9, 9 plus 2 is 11, 11 plus 2 would be 13, but that would go past my end value. So I always stop before I get to my end value. I can also make a new vector from the existing vectors. So if I say v4 equals v3, v1, I can see that what happens is all the values of v3, right, put in, followed by all the values of v1. I can also just add on to the end of a vector. So v5 is v1 with a value, and I'll see that I have all the original values of v1 with a 6 added onto the end. When I do something like this, I notice that v1 itself remains unchanged. Now if I type who's, right, I can see that all of my vector values here have varying sizes depending on how many elements are in that vector. The number of bytes that my vector takes up is always going to be the number of elements times the number of bytes that any one variable of that type would take up. So since all of my vectors here are full of doubles and a single double takes 8 bytes, if I have 4 doubles in my vector, it's going to take 8 times 4 or 32 bytes to store that vector in memory.